Y'all, Terrance Howard is at it again. And you know what? Look, I'm not going to waste too much time. Just do me a favor. Hit the like button. Hit that sub button as we're on the road to 10K. And let's hear what Mr. Howard has to say.
So to claim that a guy can't do engineering on platonic solids and come up with something new, the Rubik's Cube, the Habermas switch pitch, these things prove that that's not true.
I think it's a foolish thing almost always to pretend there's nothing new under the sun. You should always consider it.
I think that's foolish.
You might not be correct, but there's only one way to find out.
Well, there's a difference between, you see, Terrance has much greater odds of contributing to the world of engineering than he does to the world of mathematics. I mean, the odds that he's doing something new in mathematics, I'll be blunt, are very, very small.
Even though I have patents on it that shows that all of this is
I don't want to go there. The patents do not speak to what you think that they speak to.
That's okay.
Look, you can see into my heart. I'm not trying to.
No.
All right.
But we were talking. I told you that they produce a supersymmetrical structure.
When you say supersymmetry, I don't know that you know what a supersymmetry is.
What does supersymmetry mean to you, Terrance?
Supersymmetry means that all things come together, fit together, relate to each other. They're self-referential, and they are from a fractal that comes back to that same fractal space. That's supersymmetry.
So
that's not supersymmetry. Supersymmetry is the idea that for every boson, there's an accompanying fermion attached to it. Supersymmetry takes the standard model of quantum physics, and this is to my knowledge, to my understanding, I'm not an expert. It takes the standard model of quantum physics where fermions and bosons interact separately. So they do interact with each other, but they're not one and the same. So bosons control the forces. So for example, we understand gravity as a force. So if we found a related particle, that particle would be the graviton, and that graviton would be a boson. However, you have fermions that make up the matter that we interact with in touch, like electrons and protons and things like that. And fermions interact with bosons in the way that the bosons help give them their properties, from my understanding. Like the Higgs field gives fermions its mass. So in supersymmetry, as I understand it, fermions and bosons are entangled together. They are produced together. So essentially, an electron can give itself mass rather than having to interact with the Higgs field altogether. I guess the best analogy I can come up with is that instead of interacting with the owner of a home and asking for their permission to enter their home, everyone comes equipped with a key to that home and everyone has entry to it. That's what supersymmetry is, as best as I understand it. Again, I'm not an expert. I'm a regular everyday dude. I am a physics enthusiast. As Terrance explains it, that's not supersymmetry. That's just simple geometry. If you have shapes that can stack on top of each other and can be reproduced that are at certain angles, yeah, you can infinitely do that the same way you can infinitely count up by one.
So what you mean is a symmetry that is amped up, but supersymmetry is a reserved term that means something hyper-particular.
And that's what this
between
is.
bosons and fermions.
That's what this is. This is the bosons. For the layman out there, the boson, the cloud, the whole boson thing is the force field or the energy field. The fermions is considered the matter aspects of it.
So if we can go into he's got 5 of these patterns, one of which he calls the...
But what is wrong with the term supersymmetry?
Then I want to see an algebra, which is a linear vector space, which has an object called a bracket. And I want to see that bracket obeys a super Jacobi identity. And otherwise, there's no supersymmetry.
Right.
But
So it's a specifically used scientific term,
It's a
and he's using it
reserved term
incorrectly.
of art.
Yeah, but it's geometry is its own proof.
No, it's
Supersymmetry
not.
and geometry.
So I don't think they're going to touch on it, and just in case they don't, a super Jacobi, from my understanding, is a mathematical calculation that combines two things that are unrelated. So if you have A, B, C, and 1, 2, 3, obviously we know one set is letters and the other set is numbers. Your super Jacobi would find a way to combine them together to be one unified thing. And no matter how many ways you rearranged, these sets of numbers and letters, you end up with the same outcome. And Terrance also commented and said that the proof is actually in the actual shape. So you can't just have a square and another square and another square and another square infinitely stacked on top of each other, like multiple cubes inside of a cube inside of a cube, and then say, well, wow, this is such a symmetrical object, everything is even, therefore this must be a supersymmetry because I can observe the actual geometrical space. I do not believe that's how that works. So if there's any scientists out there that actually come across this video, if I'm oversimplifying any of these concepts, let me know. If my understanding is wrong, let me know. I'm very open to being corrected in the comments.
Supersymmetry in geometry allows you to visualize, like you look at the ocean and you see the supersymmetry associated with it.
I think what he's saying is you're talking about a thing and you're using the term supersymmetry, and he's saying that supersymmetry only applies to a very specific thing.
Because in their math,
it does.
No, in their math, the Platonic solids, like I said before, have a discrete symmetry.
What do you
can
mean
only
their
line
math?
up the blocks and all of those things. You can't put all of them together and tell a full story to where they fold into each other.
I don't think he's disagreeing with you with that. I think he's disagreeing the term
You're
that
using
you're
a reserved term of art.
Okay.
And you're using it incorrectly.
That's what he's saying.
And you're going to pay a penalty in which...
Okay, I don't want to pay no penalties.
Like, this is a
I got
thing
enough
where,
taxes.
like, if I'm watching an MMA fight and someone's doing...
Hang on, I gotta pause again. I mean, he said their math, right? So clearly I did see the other clips of Terrance. I didn't get a chance to react to them. I mean, he obviously has problems with math as we know it, right? I mean, he didn't understand the basic concept of multiplication. And it just seems like Terrance is trying to skip the line here and avoid all of the educational work that's required in order to invent new mathematics to solve complex problems.
Someone's doing commentary and they call a kick wrong. I'm
Right.
like, why are you doing this? You don't even know what that is. Like, you incorrectly reference something that's very specific that we've been talking about for a long time.
If you're getting intimate with your lady and you're into rough play and she's not wearing any clothes, is it a rear naked choke if she grabs you from behind? No. A rear naked choke is a particular move.
Yes,
It doesn't
very
have anything to
particular.
do with what she did.
So
Right.
you can't
So
call
is
something
there-
Unless she gets the hooks in.
supersymmetry when it's not.
Question in the world of physics, in the world of
Yeah.
mathematics, is there a supersymmetrical system, geometric system, ever been produced in mathematics?
Yes. In mathematics, yes.
What
We've
is
never
it? What
seen super Poincare algebra.
Yeah, but that's on a plane. That's not volumetrically. That doesn't scale up.
Terrance, you have an entire way of thinking that is completely foreign to everyone that I know. And I've tried to understand what it is.
Oh, I'm sorry.
No, it's not a question
No, it's not.
of that.
I don't think he's saying this is a
No,
negative.
no. I didn't see it as a negative.
What just
What
happened?
I'm trying to say is, if the reason that science works as well as it does is that up until very recently, there were clear rules, cultures. We agreed to leave certain things that are at the door, like our religious beliefs. We agreed to submit to certain sorts of things. We were decent to each other. And that system is in a process of collapse at the moment, all right? Now, Terrance comes from an earlier way of thinking, when things were much more wide open. You don't find many polymaths anywhere in a respectable position anymore. Terrance is coming from a polymathic perspective. He's all over the map in terms of the quality of his thinking. As far as I understand, some of his stuff is really, really good. Some of his stuff is offensive. And it's everything in between. Now, I'm not
That's
gunning
good.
for you.
No. I don't take that offensively.
Okay.
I take it in the fact that you're here. But let's get back to
You know, that was probably one of the most eloquent ways of saying you're not qualified. You know, we're going to get into the rest of it. I don't know exactly what Terrance Howard is going to pitch here. I mean, I see the shape over there on the left-hand side of the screen, but I just get the impression that this man is just trying to show up at the table saying, hey, man, you know, I did all the work. I discovered something, I'm just going to keep the rest to myself. Let's just finish with the video.
To what I was saying about having, if my pieces naturally come together and form those same
do and they don't.
structure. Well, here we have.
How do they not, Eric?
I'm gonna show him. Here's where 12 bubbles meet. If you go to the yellow one right there, Jamie, please tap on that. This is where the negative space where 12 bubbles meet. I call this the Arbrian. I named it after my oldest daughter.
Okay.
You can take a look
Arbrian.
at it, at how it behaves. Here, Joe.
Okay.
So you can have it, and you can have a larger one or a smaller one.
By the way, I would be honored to
I'm gonna
have
give you some of these pieces.
anything that you make of this type in my home. 'Cause it's very, very cool.
So when I put 10 of them together, they look like this.
Yeah.
I put 20 of them together, they make a natural icosahedron
Yeah.
without breaking any rules. I'm saying that the
I believe in this. This I don't disbelieve. I haven't gone through the math, but I don't disbelieve this.
I said the same thing about one other thing, so here's the.
Okay, I mean, I just don't think that he understands how geometry works. If you take a flat plane and you curve it enough, you'll get a sphere. A seemingly perfect ball, right? I mean, in these objects on screen in the bottom left, they just look to be curved triangles. I mean, I feel like I'm confusing myself trying to understand what it is that he's pitching, you know? Let me listen a little bit more and then maybe we'll figure this out.
Here's the light unit. If you'll go back to the green, Jamie, please. This is the light unit.
Now we're going to get into some stuff that's not going to be so much fun, but it is going to be, you are going to get what you want.
No, you're going to love this. You're going to love this because what I'm going to show you, as I said.
Whoa.
And what you said concerning, here.
Now look at
Hold on
that.
to
That's pretty
Put
dope.
that down, and it'll show you, this is where I've put 20 of them together. The same way I put 20 of these together, and it makes a natural dodecahedron. But what it's showing you is where electricity is being pushed into the center, and you'll see these magnetic waves coming out. It's showing you the magnetic field. So these predict and create a natural dodecahedron, whereas these come together and create a natural icosahedron. That's not something that just happens by accident.
No, this isn't an accident.
I'll put it up.
What's going on, Terrance, for me?
Can you connect all these together in one big ball of
Yes.
fury?
Yes, they just keep getting, because it's supersymmetry.
Yeah.
They all fit
I
together.
want to see
That's
these
what
and
I'm
these
saying.
together.
It ain't supersymmetry, but it's freaking cool.
Right. I know what you're saying. The
But-
problem is that term, right?
Well,
It keeps using
again,
that term.
my point is that you can run into all kinds of terms of art in a field that you don't know well.
Right.
And Terrance is like, I come on your show and I do this thing, which I've never really discussed why I do it. I have this feeling that somehow Sean Carroll 15 years ago started talking about a suite of ideas like entanglement, the multiverse, these Boltzmann brains, whatever. And people have been talking
love
about
the
them ever
idea of the
since because it
Boltzmann
was a very
brain, though. It's
successful
crazy.
tour. Much of the coolest stuff in mathematics and physics that's completely established.
You know what? For those of you who don't know, just really quickly, the idea of the Boltzmann brain is that it kind of follows the Big Bang Theory, right? So you give enough time in a vacuum with quantum fluctuations and you'll get a universe that pops into existence. But who's to say that a brain can't do the same thing and that this didn't happen and you are just a floating brain in dark space creating a reality around you. So it's absolutely insane. I mean, definitely look it up when you get some time.
Established that's non-speculative is not discussed, and I don't know why. And one of the things that I tried to do is I tried to show you the hop vibration. I tried to do the thing about the direct string trick. Terrance is bringing cool stuff from the world of geometry. It's a proof, effectively, that people don't know where it's coming from. A lot of this is real as geometry. If you look at the thing that he calls the Terranton, right?
The tetrian is the
tetrian.
The tetrian is just
so the tetrian that is the thing that is closest to us, the black thing that is closest to us.
That one.
So he then starts to make noises about it, and he says things that I don't love, which are that those faces he associates with the electric field, and the vertices, which sometimes he calls vortices, and sometimes I'm not quite sure, he associates with the magnetic field.
Yes.
Now, I don't have a clue why he says the next thing, which is, and because the number of magnetic and the number of electric things are balanced, they cancel out, and therefore it's the weak force. And to me, it's just like super cool stuff, and then suddenly turns into horseshit.
But
yeah, and I don't think, just like supersymmetry, he understands what the weak force is all about. I mean, that's part of nuclear decay and nuclear fission. You know, when stars go supernova, the weak force is partly responsible for that. I mean, nothing about what Eric Weinstein said about Terrance's shapes has anything to do with the weak force.
listen why. Here we have those two tetraons on the end. They both have equal poles, 4 electric poles and 4 magnetic poles, according to how I see it. Where magnetism is spinning.
According to how I see it? So earlier he used the term their math, and now he's saying that this is according to how he sees it. But how can we see it? How can we observe this? What tools did you use to measure? What predictions are you making? What math, again, do you have to support that this is even happening? How did you even measure the electrons between these two objects? How did you do it? Or are you just making shit up?
Off of the tips, the vortices, because it's no longer able to maintain that center space of spinning centripetally.
I don't know what the hell you're talking about.
Yeah, what brought you to that conclusion?
With what?
The way you're describing the energy involved in this.
Well, anytime you look at electricity, that was one of the things that Victor Schauberger was talking about. Electricity it's when water starts to spin to the right, it cools down. That's the natural nature of electricity. Electricity is colder. It flows better in the coldest environment. So as it's cooling down, as it's spinning down to a higher point, trying to get to that higher point, that's the highest point there. It's looking for the highest density. That's the north. North is always the highest density. South, no matter where you are, south is always away from the higher point when you're talking about universally, not talking about geographically on the earth. North is always seeking a higher position. South is always seeking a lower position. That's based upon stuff that Walter Russell talked about.
What the fuck did he just say? Huh? So water that spins to the right is always cooler, right? So if I take a stick or a paddle and I have water in a bucket, and I'm doing one of these motions, but I start doing it really, 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 really fast, right? To where I'm generating a lot of energy. Eventually, wouldn't that water begin to boil, which means that it would heat up? I mean, there's going to be friction between the water and the edge of the bucket, and again, there's lots of energy in there. The water should actually begin to get hotter, not colder. It doesn't matter what direction water is spinning in. Temperature is determined by how much energy is in an object. So water that's frozen has lower energy and more entropy than water that's normal. This is not a good look, bro.
Based upon the stuff that Victor Schauberger talked about. But it's a problem with the definition of the words, the terms.
Right, but your description of electromagnetic force and magnetism Like what is happening that it's bringing you to this conclusion that you're so specifically saying that something that you literally can't even see with the human eye is happening.
Thank you, Joe.
Very
Good question.
clearly.
I'm saying 4 magnetic fields
Right.
are pushing in on that area.
I don't see magnetic fields. I see those spheres.
Would be magnetism. What does magnetism do? It expands
But
out.
what brings you to the
No.
conclusion that
Radiation.
electric?
Well, let's say radiated field. Let me use the term
Do you know
radiated
do you know
field.
what we think electricity and magnetism are?
You think that it's the same thing,
No.
part of the same force.
What
They
do
have
you-
them
what
coupled
do you
together.
Jamie, could I ask you to find a Faraday tensor?
Yeah, what I was trying to get to the conclusion, like magnetism and electricity, like what brings you to this definitive conclusion that you can so clearly state that this is what's happening there?
Well, based upon any time there's an electric force acting on something, it causes a cavity. Electricity is always pulling in from the inside. It's always trying to tighten the density.
And you
Whereas-
assume this energy exists in the flower of life. Why?
because that's where all those circles, the overlapping circles, they represent the magnetic field. They represent the radiative field that's
Why?
coming out and coming back. Well, why does a bubble take the shape of a ball? Why not a square or a triangle? What's the why does it expand
A
into a
bubble-
sphere?
There's a lot of reasons why a bubble takes the shape of a bubble. I mean, a sphere is an easy object to make when you have action happening all over in an easily influenceable and moldable object. I mean, it's like having Play-Doh or a flat piece of paper that you ball up. That's the equivalent of creating a bubble. Any other shape would be far more difficult to actually occur naturally. I mean, do we have a square star or a square planet or a triangular planet? The most natural shape in the universe is a circle or a sphere.
Sphere.
A sphere is an abstraction that it's going to be the solution to many different problems. If I ask you to give me the maximum possible volume with the minimum possible area, I'm going to get a sphere. If I ask you what is the best thing to launch out of an old style cannon and to stack next to it, you're going to say a sphere. Then you have a question about, is that the same
example.
concept of a sphere? You know, if I take the three-dimensional sphere of unit quaternions, is that the same concept of a sphere? You are, in part, freely associating, repeatedly, between things that remind you of other things. Now, you have an incredible storehouse of things between your ears that you know to associate with. And your brain is like, I mean, in part, it's like, if you think about the totality of your brain, it's like a Ferrari engine and a Volkswagen. The Volkswagen chassis is not capable of supporting something else that you're doing really well. And so what you're constantly doing, as far as I can tell,
So the chassis being education, formal education.
it's not just that. I mean, it's in part, people who see many connections are often bad at cleaning up their own stuff. And people who don't see connections
Bar.
are often very rigorous and they don't do shit for their entire life.
All right, guys, that's going to be it for the video. And I'm not going to lie, I'm absolutely cooked. I mean, if you couldn't tell, right, at the start of the video, you know, I was a lot more coherent and far more articulate in my speech. But as time went on and I had to try to wrestle with what Terrance was actually saying, it just made it far more difficult for me to actually articulate myself because I kept getting confused between what was, I don't know, like, it's kind of like between what was real and what he was saying. Like, I knew what he was saying was wrong, but I was just so stuck on his ideas that I couldn't really kind of connect and put my words together. And I'm still sort of in that state now, but I don't know what's going on with him. I don't know where this interest is coming from. I mean, I think he's been interested in this stuff for a long time. I think he's had patents that dated back years. But again, I mean, anyone can go and file a patent. You know, are these patents even secure? Like, did he even get the patents, right? But this media coverage needs to end. We don't need to put these types of things on display. I'm not saying that he's not allowed to be a free thinker and do his own thing, However, it's really reckless to air this type of shit online. I mean, it didn't make any sense. He talked about electromagnetic forces pulling things in, and that his I can't even remember the names. All Brarians are, I don't know. They're interacting with electric forces, magnetic forces, and radio waves underneath. I'm not even sure if I'm paraphrasing it right. That's how little sense it actually made. But I enjoyed being able to talk about physics for a little bit because, again, I have been a enthusiast for a long time because I feel like physics describes the world as best as we interact with it. But I'm actually going to end it here. Hopefully we never have to see Terrance again. And if this video ends up popping off, I'll change my mind and hopefully we do see Terrance again. I'm not quite sure. Leave the video a like if you like the video. And definitely subscribe to the channel as we're on our way to 10,000 subscribers. That's our goal. And I'll catch you guys in the next one.